Hello and welcome to Cashmatics. This tutorial will show you how to differentiate exponential and logarithmic functions. Now you're going to need to know the basics of logs, and I'll recap those rules really briefly. But if you are rusty, I suggest that you take some time out to revise those rules thoroughly. Now it's going to be a short and sweet video, but there's a lot to take away from it, so please be ready to make some notes. Anyway, grab some paper and a pen and let's get started. Before we begin, I'm just going to recap the basics of logs and exponentials. So pay attention to this part because everything we're going to do after this, relies on you knowing what we're going to do here. So on this screen here, we've got loads of different rules which you should already be familiar with. So the basic rules of logs. So the log of p plus the log of q is the same as the log of pq. The log of p take away the log of q is the same as the log of p over q. And remember, these rules work in reverse as well. The log of p to the power q is q log p, so I can bring this power down and put it at the front there. So that's the first set of rules. Those are for logs. Now differentiating e to the power x, if y is equal to e to the power x, then dy by dx will also be e to the power x. So e is one of those special numbers that when you differentiate it, you get exactly the same function again. But if y equals e to the power ax, dy by dx will be a e to the power ax. Okay, so this one in blue is going to be really important for the first lot of examples. The natural logs, e to the ln x is x, and ln of e to the x is x. So what we've got here is a function and its inverse function. Okay, ln x and e to the x are inverse functions of each other. So if you apply both those functions to x, you'll end up back where you started with, which is x. And lastly over here, differentiating ln x, if y is equal to ln of ax, okay, when you're differentiating ln of anything, it becomes 1 over that function, and then you multiply it by the derivative of that function. So the derivative of ax is a, which is what we've got here. So it's 1 over ax multiplied by a's cancel out to leave you with 1 over x. But in general, if y equals ln of f of x, so some function of x, it'll be 1 over that function multiplied by the derivative of that function. So again, this rule we've got here in white is going to be really important when we go and do the examples on logs. So please make a note of anything you need to there, because everything we're going to do from now relies on you knowing this. Now we know that y equals e to the power x, when differentiated, becomes e to the power x. And that only works because this e is a special number which when differentiated gives you exactly the same function. But if instead y is equal to a to the power x, okay, we can't do it so easily. So what we do is we use some clever trickery when it comes to exponential and logs to help us along the way. So let's say e to the ln x is equal to x. That was on the last screen. Okay. Now I can rewrite this to look like this. So let me show you what I mean. I can say y is equal to e to the ln of a to the power x. Okay, so instead of having an x there, whatever that is there, whether it's x, no matter what it is, as long as I have e to the ln of that term, it's the same as just having that term. So this here is the same as a to the power x. So if you compare the two, you should be able to see where that comes from. Now what I do now is use some of my log rules. So I've got some number to a power here, so I can bring the power down. So that I can rewrite that as e to the x ln a. And what I'm going to do here is I'm going to use what I've learned from the last slide about differentiating, because we said that if y is equal to e to the ax, in fact I'm not going to use a because I've got an a here, so let's just say bx, then dy by dx would equal be to the bx. Okay, now in our case the b is your ln a. Okay, that's your constant, it's just a number. Ln a is just a number, right? So what we're actually going to get is dy by dx. Now if you look at it, if that's like your b, okay, so look where it ends up, that would equal ln a e to the x ln a. Okay, so take your time to see what's happened there, okay, because this step is really important. What I can do now is I'm going to keep that ln a there, and I'm going to rewrite this back the way it was. Okay, so if you think about it, I'm just going to take a backward step here. I'm going to say that's e to the ln a to the power x. I'm putting it back in the power. Okay, so that's ln of a. And look at this here. E to the ln something is just the something, so multiplied by a to the power x. And we'd normally write that in this order. A to the power x ln a. And that's a standard result. Okay, that's a standard result. So if y is equal to a to the power x, then dy by dx is equal to a to the power x ln a. Okay, so that's definitely worth writing in your notebooks. But it is really important that you actually practice this as well. Okay, because if in an exam you're asked to prove that result, you're going to get lost somewhere unless you practice this. All right, so there's a lot of information to absorb here. Okay, a lot of skills which come into play. Okay, so you've really got to understand your exponentials. You've really got to understand your logs in order to be able to do this. So make some notes and we'll do another example. Okay, let's say this time we've got y equals 5 multiplied by 2 to the power x. Okay, so 5 multiplied by 2 to the power x. In fact, what I'm going to do is I'm going to write it like that in brackets. Now, one thing you mustn't do is think of that as 5 times 2 making 10 and writing 10 to the power x, okay, because that would be completely wrong. It's 5 multiplied by whatever 2 to the power x is. So the way I'm going to deal with this is I'm going to say y is equal to 5 multiplied by e to the ln of 2 to the power x. So very similar to what I've done before. The only difference is I've got a 5 in front of it, which isn't going to actually change anything until the end when it's going to be multiplied by 5. Okay, so 5 e to the x ln 2. Okay, so dy by dx, I'm ready to do that now. It's going to be ln 2 e to the x ln 2. And what I can do now is tidy that bit up. Okay, so this here is the same as e to the ln of 2 to the power x. I'm probably taking more steps here than I normally would, just so you can follow it. ln 2 multiplied by 2 to the power x, and then I can just go ahead and write my final answer. So I'd probably write it as 2 to the power x multiplied by 5 ln 2. Okay, so that's probably how I'd write it. In fact, I'd probably put it in brackets like that just to make it a little bit tidier. So that's what dy by dx is. So make some notes from that, because the questions I'm going to give you are going to be very similar to what we've got here. Now, before we move on to the questions, I'm going to do some examples with the natural logs as well. So let's say we had y equals, now the simplest is just ln x, okay? And hopefully you know that dy by dx will just be 1 over x. If I had y is equal to ln of 2x, now I'm going to show you how to do this in 2 different ways. Let's just make this a little bit neater. So y is equal to ln 2x. Now, the first thing I can do is split this up. This is a product. I can write that as ln 2 plus ln x. Okay, and when you differentiate, what you've got to remember is any constant, okay, that's just a number. ln 2 is just a number. Any number disappears and becomes 0. Plus ln x, which is just 1 over x. So the final answer is 1 over x. The other way of doing it is by using 1 over 2x, okay, so remember it's 1 divided by the function. So the function of x is 2x, okay, so it's 1 over that multiplied by the derivative of this, which is 2. And you see the 2's cancel out to leave you with 1 over x. So as long as I'm applying my log rules correctly, I can do it this way or I can do it this way. Okay, you end up with the same result. And I'll do another one which is slightly more complicated to show you that you'd still end up with the same answer. So make a note of that one, and then we'll move on to the next example. In this example, we've got y equals the natural log of 5x cubed. Now I'm going to do this in 2 different ways. Now the first way is just by splitting everything up. So I'm going to write that as ln 5 plus ln of x cubed. And then I'm going to say that's ln of 5 plus 3 ln x. Okay, so I brought the power down to make the 3 ln x. So remember, this is y. I've not differentiated it yet. Let's differentiate it now. Dy by dx, that just becomes a 0. Remember, that's just a constant, plus 3 times the derivative of ln x, so that'd be 3 multiplied by 1 over x, leaving me with just 3 over x. Okay, so that's the first way to differentiate that. The second way is by applying the rule I had in the first page, which was dy by dx is equal to 1 over the function multiplied by the derivative of the function, which would be 15x squared. Okay, so the x squared would cancel out with x squared from the bottom, leaving me with just x on the bottom. Okay, and the 15 divided by 5 leaves me with a 3 at the top. So I get 3 over x. So I get exactly the same result. I've just gone about it in a different way. Now I hope that's made sense, because the questions you're going to do are going to rely on you understanding that. So make a note, go back if you need to, read the examples again, and then get ready for the questions. So here we go. Here's 4 questions for you to try. Be careful, take your time, and yeah, see how you get on, and I'll reveal the answers shortly. Right, so I hope you've had time to try those questions, and here are the answers. Right, okay, so read through those carefully, compare them what you've got, and the last 2 questions I've done it in 2 different ways, so you can see the alternative method to get to the answer. Anyway, I hope that's helped you to understand exponentials and logarithms when it comes to differentiation, and that's all for now, and I'll see you next time. Bye-bye.